Composite functions. So, what is a composite function? That's basically when you substitute a function into another function. So you sort of combine functions together and obviously then creates a new function. Just something like this. Say this is our domain, there's our x values, 1, 2, 3, 4, 5, and there's the rule for our function, 2x plus 1. So 1 would go to 3, 2 would go to 5, 3 would go to 7, 4 goes to 9, and 5 goes to 11. So any x value would go to 2x plus 1. But then we're going to get this new set of numbers, and we're going to apply another function to it, 3x squared. So now the 3 goes to 27, the 5 goes to 75, 7 goes to 147, 9 goes to 243, 11 goes to 363, and the 2x plus 1 goes to 12x squared plus 12x plus 3. So of course it's equivalent to if I'd got the first number and put it into 12x squared plus 12x plus 3. There's our notation, g function x. So basically it's saying we have substituted function x into g of x. And as we see, that's 12x squared plus 12x plus 3. The interesting thing is if we did it the other way round, you generally get a different function. It's very rare you get the same. Sometimes you do, but it's very rare you get the same. In fact, for our one, if we were to substitute gx into the function, so now 3x squared I'm subbing into 2x plus 1, we'd end up with 6x squared plus 1. So a different function altogether. So the question arises, well, all right, how do we work out the domain and range of these composite functions? Okay, here are the rules. For an x value to be in the domain of the composite function, so we're subbing gx into function x, two conditions. First of all, x needs to be in the domain of gx. Well, that makes sense. If I can't substitute it into gx, then the gx can't be substituted into function x. So the first thing, it's got to be in the domain of gx. But then the actual answers to gx, or the range if you like, must be in the domain of function x. Because what we're saying there is, well, the answers that we get out, we're going to substitute into the function. So if that answer is not in the domain of the function, then that original x value that we subbed in is no good now, because it comes up with a number that I can't substitute into gx. Now, range. So the answer to function gx is in the range of the composite function only if the x value that you substituted in is in the domain. Well, that would make sense. If it's not in the domain, then you can't get an answer. Okay, let's have a look at this one. Function x is going to be 2x over 4 minus x, gx 1 over x squared. So we want to find the domain and range of this function when we substitute in gx into function x. So there's gx, 1 on x squared. Let's just look at the domain of that. Well, we know that's all real numbers except 0. The range ends up being, it's got to be greater than 0, because 1 on x squared, you would never get any negative numbers. The other function, 2x on 4 minus x, domain all reals except 4. You can't get 4. The range for that one turns out to be all the real numbers, but we won't get the answer of -2 for that one. So our rule was, x must be in the domain of gx. Okay, well gx, let's just go back there. Remember we said the domain of gx was all real numbers except 0. So we know, all right, x equals 0 is not in the domain of this function. Gx must be in the domain of the function. Well, we said g of x cannot equal 4. Therefore, 1 on x squared cannot equal 4. So x cannot equal plus or minus a half in this situation. So we have 3 exclusions from the domain, 0 and plus or minus a half. Now the range, we said this, a value of function gx is in the range of the composite function only if x is in the domain. I just find it easier to work out what the actual function is and look at that. So here's function g of x, sub it in, I get 2 on 4x squared minus 1. So I know the range becomes less than or equal to -2, union, also when function g of x is greater than 0. That would be our range of that function. However, remember we said x can't equal 0 up here. Therefore I can't substitute 0 into this function. Therefore, I can't get the answer -2. So I have to modify my answer here, because originally I had less than or equal to, but actually no, it can't equal to. So it'll just be the functions less than -2 along with all the positive numbers as well. Can be tricky though. Let's go the other way around then. What happens if we substitute function x into g of x? X must be in the domain of function x. Well, we said x can't equal 4, right? So we know 4 is an exclusion. Function x must be in the domain of gx. Our answers for function x was, we got everything, but we didn't get 0. So therefore 2x on 4 minus x can't equal 0. That comes up with x can't equal 0. So we've got x can't equal 0 or 4. Now the tricky bit, the range. Let's work out the composite. The composite is 4 minus x all squared over 4x squared. The range of that is positive numbers. I've got a square on a square. It's got to be a positive numbers. However, we know x can't equal 4. We said that up there. So therefore I can't substitute 4 into this, which means I can't get the answer 0. So my range is just all the positive numbers for that one. If it turns out the domain is empty, it's a very strange function you've got there, because we're saying, actually I can't substitute anything into this. So if the domain is the empty set, then the function is called the empty function. It's sort of like, it's nothing. It doesn't exist sort of thing. Look, we'll do a handful of questions out of 4E here. I'm sure this will bring up a few questions, I'm sure.